So let's start. What does SRE stand for? So SRE stands for Site Reliability Engineering. The simplest way to understand SRE is the practice of applying software engineering principles to IT operations and reliability. Now that the definition might sound complicated if you are a beginner, so let's simplify it. Imagine that you work for an online shopping company. Customers use your website or application to search for products, add products to their cart, make the payments, place orders, and track the deliveries. Now imagine that suddenly the website becomes extremely slow, or the payment service stops working, or the application crashes, or the database becomes unavailable. Customers can't place the orders. The company starts losing money. This is where reliability becomes extremely important. The SRE team's responsibility is to help make sure that the systems are available, reliable, scalable, performant, and recoverable when things go wrong. So you can think of an SRE as someone who asks, how can we make sure our production systems continue working reliably even when failures happen? Now coming to part 2, why was SRE created? To understand SRE properly, you need to understand the problem it was created to solve. Traditionally, software development and IT operations were often treated as separate responsibilities. Developers would write the application, operations team would deploy and maintain it. Developers might say the application is ready, deploy it. Operations might say, okay, we will deploy and maintain it. But then problems started happening. The developers wanted to release the software faster. Operations wanted to keep the production environment stable. Developers might say we need to deploy this feature today. Operations might say we don't want to deploy it because it could break the production. So there was a conflict. One side wanted speed, the other side wanted stability. SRE tries to solve this problem using engineering. Instead of relying entirely on manual operational work, we use automation, monitoring, software, metrics, reliability engineering, incident management, capacity planning, and systematic approaches to failure. The idea is don't just operate the systems manually, engineer them to be reliable. Coming to part 3, SRE and Google. Here is an important piece of SRE history that is very useful in interviews. SRE originated at Google. One of the key people associated with the development of SRE is Ben Trenor-Sloss. Google's environment was operating at enormous scale. When you have millions or billions of requests, thousands of machines, and constantly changing software, you cannot depend entirely on people manually keeping everything healthy. You need engineering, you need automation, you need measurable reliability. That is where the SRE approach became extremely important. A famous way of describing SRE is what happens when you ask a software engineer to design the operations function. You don't need to memorize that sentence word by word, but understand the idea behind it. Operations problems are approached as engineering problems. That's the basic idea in SRE. Now coming to part 4, what does an SRE actually do? Now let's come to the question that almost every beginner asks. What does an SRE actually do? An SRE can work on many different areas. For example, first is monitoring. An SRE needs to know whether the system is healthy. We monitor the things such as CPU usage, memory usage, disk usage, latency, request rate, error rate, availability. We will study monitoring and observability in much more detail later in this series. Second comes incident response. Imagine your production application suddenly goes down. Someone needs to detect the problem. Someone needs to investigate it. Someone needs to mitigate the impact. Someone needs to communicate with stakeholders. And after the incident, the team needs to understand why it happened and prevent it from happening again. That's what incident management is. Third is automation. Suppose an engineer has to manually restart a service every time something fails. Doing that once isn't a big deal. Doing it hundred of times isn't efficient. So SREs look for ways to automate the repetitive operational tasks. This could involve scripts, CI/CD pipelines, infrastructure automation, configuration management, Kubernetes, cloud automation, and other tools. Now fourth is capacity planning. Suppose your application normally receives 10,000 requests per minute, but during a festival sale, you expect 1 million requests per minute. Will your system survive? Do you have enough servers, enough CPU, enough memory, enough database capacity? Can your infrastructure scale? This is what capacity planning becomes important. This is how we do the capacity planning. Now, coming to performance, an application doesn't necessarily have to be completely down to have a reliability problem. Suppose your website normally responds in 200 milliseconds. Suddenly, it takes 10 seconds. Technically, the website is still working, but for users, it's practically unusable. So, SREs also care about performance and latency. Sixth is reliability engineering. SREs continuously look at how do we make the system more reliable. That could involve redundancy, fault tolerance, high availability, disaster recovery, graceful degradation, load balancing, auto scaling, monitoring, and many other techniques. We will cover these throughout these 90-day series. Next is part 5. SRE is not just monitoring. This is an important point. Many beginners think SRE means monitoring servers. No, monitoring is only one part of SRE. Similarly, SRE is not just Kubernetes. SRE is not just AWS. It is not just Linux. It is not just writing the scripts. It is neither just responding to incidents. All of these can be a part of an SRE's work, but SRE is fundamentally about reliability engineering. Coming to part 6, what does reliability actually mean? Let's understand the word reliability. Suppose you have a banking application. Users expect it to work when they need it. If the application randomly crashes every few hours, users will lose the trust. So, reliability means that a system consistently performs its intended function correctly over time. Reliability can involve multiple things. It could be availability, is the service available? Performance, is the service responding quickly enough? Correctness, is the service actually producing the correct results? Durability, is the data protected from being lost? Scalability, can the system handle increased demand? Recoverability, can the system recover when something fails? So, when we talk about SRE, we are talking about much more than simply keeping the servers running. We are talking about keeping the service reliable. Coming to part 7, SRE versus DevOps. Now let's address one of the most important interview questions. What is the difference between SRE and DevOps? First, understand something important. SRE and DevOps are not completely unrelated technologies. They are approaches and practices. So DevOps broadly focuses on improving the collaboration and flow between the development and the operations team with automation and faster and safer software delivery being the major themes. So, SRE applies the software engineering techniques to the problem of operating reliable production systems. A simple way to remember this is DevOps always asks how can development and operations team work together efficiently to deliver the software. But SRE asks how can we operate and engineer that software so that it remains reliable at scale. So there is a lot of overlap. An SRE may use Git, CI/CD, Docker, Kubernetes, Terraform, AWS, monitoring, automation, just as a DevOps engineer might. So don't make the mistake of saying DevOps and SRE are completely different. They are not. There is a significant overlap between them. Coming to part 8, SRE versus system administrator. Another common interview question is how is SRE different from a traditional system administrator? So, a traditional system administrator may focus heavily on servers, operating systems, networking, user management, patching, backups, and system maintenance. An SRE can also work with these areas, but SRE emphasizes software engineering and automation at scale. For example, a traditional approach might be the server is down, I will manually restart it. But an SRE approach asks, why did the server actually go down? How did we detect it? Can we automatically recover it? Can we eliminate the underlying cause? Can we make the system tolerate this failure? That's the engineering mindset. Now, coming to part 9, the SRE mindset. This is one of the most important things I want you to understand during this entire series. Don't approach SRE as I need to memorize 500 interview questions. Instead, develop an engineering mindset. When something fails, ask what failed, why did it fail, how did we detect it, what was the impact, how did we recover, how can we prevent it from happening again, can we automate the solution. This is the way of thinking. This will help you answer the questions you have never seen before, and that's exactly what you need in an actual interview. To part 10, SRE and production. Let's understand another important word, that's production. Production is the environment where the actual users use your application. For example, imagine you have development, then testing phase, then staging phase, and production phase. So developers might write the code in development. The code may then be tested, it may be deployed to staging, and eventually it reaches the production. Production is extremely important because real customers are depending on it. Now, if production goes down, there can be financial loss, customer dissatisfaction, reputation damage, SLO violations, and sometimes serious business consequences. That's why reliability becomes a business concern, not just a technical concern. Coming to part 11, what is an incident? Let's understand another fundamental SRE term. An incident is an event that causes or threatens to cause a disruption of a normal service. For example, your API starts returning HTTP 500 errors. That could become an incident. Your database becomes unavailable. That is also an incident. These type of things can become an incident. Your application latency suddenly increases dramatically. That could also become an incident. An incident doesn't necessarily mean the entire application is down. Any disruption can be treated as an incident. It can mean that an important aspect of the service is degraded. So SRE teams need processes to detect, respond to, mitigate, and learn from the incidents. We will have a very dedicated session on incident management later in this series. Coming to part 12, what is an SLA? Let us understand this. SLA is service level agreement. An SLA is an agreement between a service provider and a customer that defines the expected service levels. For example, a company might commit to a certain level of availability. The important thing is SLA is generally an external or business commitment. For example, we commit that our service will be available 99.9% of the time. That's an SLA type of commitment. Like we are committing the business that it will be available 99.9% of the time. Coming to the next part, what is an SLO? SLO is service level objective. An SLO is a target for the reliability of a service. For example, we want our API to have 99.95% availability. That's a SLO. A simple distinction between SLA and SLO is SLA is commitment or agreement, but SLO is something we are targeting or it's an objective. We target to achieve it. SLO is a target to achieve, but SLA is a commitment. It's an agreement with the business. To the next part, what is an SLI? SLI is a service level indicator. An SLI is the actual measurement of service performance. For example, suppose our SLO is 99.9% of successful requests. Now we need an actual measurement to determine whether we are meeting that objective or not. So that actual measurement is SLI. So SLI is the actual measurement of the service performance. SLO is what we are targeting or what the objective is. We measure it that we have actually achieved it or not through SLI. SLI is agreement or commitment to the business. This distinction is very important in SRE interviews. To the next part, what is an error budget? So suppose your SLO says the service should be available 99.9% of the time. That means you are allowing a small amount of unreliability, right? That allowed unreliability is your error budget. For example, if the SLO is 99.9% availability, then approximately 0.1% represents the allowed unavailability over the relevant measurement period. The purpose of an error budget is to balance reliability with innovation and release velocity. Now, if the service is extremely reliable and the team has plenty of error budget remaining, the organization may have more room to release the changes. If the team is continuously exhausting the error budget, it may be necessary to prioritize the reliability work. This is a fundamental SRE philosophy. We don't simply say make the system 100% reliable, because achieving the absolute reliability can be extremely expensive or practically impossible actually. So instead we define an acceptable reliability target. We can say that 99.9% of the time the system will be up, 0.1% there can be failure. Next part is availability versus reliability. These two words are sometimes used interchangeably, but you should understand the distinction. So availability generally asks, is the service accessible and functioning? Reliability is broader. A service can technically be available but still have reliability problems. So you need to understand this. For example, your website responds to every request, but 30% of the requests return an incorrect result. The service is technically available, right? Because it is returning a response for every request, but that's still a reliability problem because 30% of the requests are incorrect results. So remember, availability is one aspect of reliability. The next part is high availability. Another concept you will hear frequently is high availability or HA. The goal of high availability is to minimize the service downtime. Suppose you have only one server. If that server fails, your application goes down entirely. That's a single point of failure. Instead, you might have multiple instances behind a load balancer. If one instance fails, then traffic can potentially be sent to another healthy instance. That's one example of designing for high availability. Later in this series, we will go much deeper into redundancy, failover, load balancing, fault tolerance, disaster recovery, and multi-region architecture. The next part is automation in SRE. This is one of the biggest themes you will see throughout this series. Imagine an SRE performs the same manual task 50 times every week. Instead of repeatedly performing it manually, we should ask, can we automate this? Automation provides several benefits and reduce the human error, save the time, improve the consistency, allow the systems to scale, and free the engineers to work on high value problems. This is why you will see technologies such as Linux, Python, Bash, Git, CI/CD, Docker, Kubernetes, Terraform, Ansible, and cloud platforms in SRE ecosystem. But remember, learning the tools is not the same as understanding the SRE. The tools are there to help us solve reliability and operational problems. To the next part, what skills does an SRE actually need? There isn't one universal checklist because SRE roles differ between the organizations, but generally you should be comfortable with several areas. First one could be Linux. You should understand the processes, memory, CPU, file systems, permissions, networking, logs, services, troubleshooting, and shell commands. Then comes networking. You should be able to understand the concepts such as IP, DNS, TCP, HTTP, HTTPS, ports, load balancing, proxies, and firewalls. Programming and scripting. You should be able to automate tasks using languages such as Python, Bash, Go, depending on the role. Next is Git. So you should be able to understand the repositories, branches, commits, merge, pull requests, and conflict resolution. Next comes CI/CD. You should be able to understand how the code moves from development into production safely and automatically. Then comes containers. You should understand the Docker, container images, registries, container networking, and storage. For Kubernetes, you should understand pods, deployment services, config maps, secrets, ingress, scaling, scheduling, and troubleshooting. For cloud, you should understand at least one major cloud platform depending on the job. It could be AWS, it could be Azure, it could be Google Cloud. Monitoring and observability, you should understand the metrics, logs, traces, dashboards, alerting. For SRE concepts, you need to understand the SLI, SLO, SLA, error budgets, incidents, postmortems, availability, reliability, scalability, and capacity planning. And don't worry if these terms seem overwhelming right now. That's exactly why we are doing this 90 days ka series. Coming to the next part, let's look at a real world example. Let's put everything together with a simple example. Okay, so imagine we have an online food delivery application. A customer opens the application, they search for a restaurant, they place an order, the application sends the requests to several services. We have a mobile app, a load balancer, an API service, an order service, and a database. Perhaps other services such as payment service, notification service, restaurant service. Now imagine the database becomes extremely slow. The order service starts responding slowly. Customers wait for 20 seconds to place an order. Some request to timeout. Customers start complaining. What would an SRE think about? First, the SRE should think about how do we know there is a problem. Monitoring and alerts. This is how we can know where the problem is. Second, what exactly is failing? This could be known through metrics, logs, and traces. Third is what is the impact? How many users are actually getting affected? Fourth is how do we mitigate the problem? Perhaps scale the service, fail over to another component, reduce the load, or roll back a problematic change. Depending on the situation, we take a decision. Fifth could be why did it happen? Perhaps the database reached the capacity. This could be one reason. Sixth is how do we prevent it from happening again? Maybe we need better capacity planning. Maybe we need improved monitoring, improved auto-scaling, database optimization, better alerting, or architectural changes. That entire thought process is very much aligned with an SRE mindset. The next part, it's a common beginner misconception. So before we move to interview questions, let's clear up some misconceptions. The first is SRE is just DevOps with a different name. Not exactly. There is a significant overlap, but SRE has a strong emphasis on measurable reliability and engineering the production systems. Conception 2 is SRE only monitors the servers. No, monitoring is only one part of SRE. Misconception 3 is an SRE must know every tool. No, tools change and they evolve. So the important thing is understanding the underlying concepts and being able to learn and use the tools to solve the problems. Misconception 4, SRE means preventing every failure. That's unrealistic. That is not even possible. Failures will happen. The goal is to design the systems that can detect, tolerate, mitigate, recover from, and learn from failures. Now, moving to the next part, this is day one interview questions. I want you to actually practice answering this. Don't immediately look at the answers. Pause the video, try to answer each question yourself. Question 1, what is SRE? A strong beginner answer would be SRE stands for Site Reliability Engineering. It is an approach that applies software engineering principles to IT operations and production systems with the goal of improving reliability, availability, scalability, performance, and automation. Question 2 is who actually introduced SRE? So a good answer would be SRE was originated at Google, and Ben Trenor-Sloss is one of the key figures associated with its development. Then comes question number 3, why was SRE created? So SRE was developed to apply software engineering principles to operations and reliability challenges, particularly at large scale. So it emphasizes automation, measurable reliability, and engineering solutions instead of relying heavily on manual operational work. Next is question number 4, is SRE the same as DevOps? So no, they overlap significantly, but they are not exactly the same. DevOps broadly focuses on collaboration and efficient software delivery between development and operations, while SRE applies engineering principles specifically to operating the reliable production systems. Question number 5 is what does an SRE do? An SRE works on maintaining and improving the reliability of the production systems. This can include monitoring, incident response, automation, capacity planning, performance optimization, scalability, and reliability engineering. Next is question number 6. What is an SLI? SLI stands for Service Level Indicator. It is a quantitative measurement of a service's performance or reliability. Next is what is an SLO? SLO stands for Service Level Objective. It is a target level of reliability or performance that a service aims to achieve. Next is what is an SLA? SLA stands for Service Level Agreement. It is an agreement or commitment between a service provider and a customer that defines the expected service levels. Then comes what is an error budget? So the answer is an error budget represents the amount of unreliability that is acceptable according to an SLO. It provides a balance between maintaining reliability and allowing teams to release and innovate. What is the difference between SLI, SLO, and SLA? This is something you should absolutely remember. So SLI is a measurement, SLO is the target, SLA is the external agreement or commitment. That's very interview friendly way of remembering it. Then comes why is automation important in SRE? So automation reduces the repetitive manual work, improves the consistency, reduces the human error, increases the operational efficiency, and allows the systems and operations to scale. Then comes, does SRE mean preventing all the failures? No, failures are inevitable in distributed and complex systems. SRE focuses on designing systems to detect, tolerate, mitigate, recover from, and learn from failures while maintaining an acceptable level of reliability. And that's it for day 1 of the 90 days SRE interview series. If you are completely new to SRE, don't worry if some of these terms sounded unfamiliar. We are going to build everything step by step. Tomorrow we are going to move into the next important foundation, and I want you to do one thing before you leave. Take a notebook and write down these 5 terms: SRE, SLI, SLO, SLA, and error budget. Try explaining each one without looking at your notes, because throughout this 90-day series, I don't want you to simply watch the videos. I want you to learn, practice, and become interview ready. So if you're serious about becoming an SRE, subscribe to the channel, join me for the next 89 days, and follow the playlist. If you have any doubt from today's video, you can comment that in the comment section and I'll be more than happy to help you out. And if you have any suggestions for me to change the teaching style or to explain in a certain manner, I will be happy to incorporate that in my videos. If this video helped, thanks for watching. Please like, share, and subscribe to my channel.